Hi everyone, my name is Amanda and I'll be presenting our research titled Sign Language Video Retrieval with Freeform Textual Queries. This work was done in collaboration with Samuel Albany, Xavier Giró, and Gil Varel. Let me begin by presenting the task proposed in this work. Given a written query, for example, a sentence, and a large collection of sign language videos, we want to retrieve the signing video in the collection that best matches the written query. We propose to do so by training a cross-model embedding between the sign videos and the textual query in which we explain in detail throughout this presentation. Such task has a broad range of applications. Such examples include indexing signing videos to enable efficient search, develop tools to automatic data collection and annotation, create tools to support sign language learning, making voice-activated devices respond to sign, and among others. In this work, we assume access to a parallel corpus of signing video with corresponding written translations, and we aim to learn a pair of video and text encoder, which map each signing video and text into a common embedding space, such that they are closed if the text corresponds to the content of the video. To learn the encoders, we adopt the cross-model ranking learning objective proposed by Soher et al., referred in the bottom of this slide. The inference is done by computing the cosine similarity between the text query and every index signing video to produce the ranking, and vice versa when applied to the video-to-text task. To implement the text encoder, we first embed each text sample using a language model that has been pre-trained on a large dataset of written text. The resulting sequence of words embedding are then combined and projected into a fixed-size vector. On the other hand, the sign video encoder consists first of our initial sign video embedding, which was initialized as an I3D network. The output of it is temporarily aggregated to a fixed size vector and then projected to the cross-model embedding space. In addition to the cross-model retrieval embeddings, the sign recognition model used to train the sign video embeddings can be used to obtain a sequence of signs if applied in a sliding linear manner in the long sign video. The output list of the predicted sign categories gives us a set of candidate words, which we compute the intersection of a reunion to check the overlap with the query text. We observe here that the initial sign video embeddings has a big influence on the performance of the overall retrieval. However, one of the key challenges to obtain a good sign video embedding is the lack of annotated sign language data. To address this challenge, we propose the Spotlight framework, which we use to obtain a large number of automatic sign annotations on the How to Sign dataset. We start by obtaining a first set of sparse annotations using two previous sign spotting techniques based on the mouthing and dictionary examples. Both works are listed in the bottom of this slide. We observe that the output of the dictionary-based sign spotting method is limited to the domain gap between the videos of the How to Sign and the datasets used to obtain the dictionary exemplars, as you can see in this example. To improve that, we propose the retraining requery framework that is designed to improve the feature alignment between both video domains. We increase the amount of dictionary-based annotations by retraining our sign video embeddings and requerying the dictionary exemplars. Now let's take a look at the retrieval results we obtain by using different sign video embeddings. We compute the required K metric, in this case K being 5. We present on the left the results when using the output of the sign recognition model, in which we use the text-to-text matching. And on the right, the learned cross-model embedding, which performs better than the text-based models. Looking at some qualitative results, here we can see some examples where our method can successfully retrieve the video that corresponds to the textual query. And in this example, we can see some failure cases where our method struggles to retrieve the correct video when it's given the less detailed query. You can find a complete set of experiments and more qualitative results in our paper and also in our project page. Thank you.